Hello and welcome to Just Have a Think. Here's a stat for you. According to the United Nations, there'll be about 70 million new people moving into cities every single year between now and the mid part of this century. And that's more than the entire population of the United Kingdom. And at current consumption rates, that move just on its own will put nearly 230 billion extra tonnes of carbon dioxide into our atmosphere. So the race is on to establish how we can transform our cities into digitally smart, climate resilient, adaptive and sustainable environments. And if we can't achieve that, we can wave bye-bye to any hope at all of keeping the global temperature rises to within 2 degrees Celsius, let alone the 1.5 degrees Celsius that this report aspires to. Love them or loathe them, urban environments offer huge cost effectiveness, job creation opportunities, gender equality and inclusivity, and crucially, if they can be designed and developed and built with an ultra-low carbon emission footprint, then they might even minimise the need to deploy untested geoengineering technologies like carbon dioxide removal and solar radiation modification. We'll have a look at those two technologies next week, but this week we're focused on urban infrastructure and industrial system transitions. Architects and planners, as well as the IPCC in this report, tell us that there's huge upsides to human beings living in cities, but they also caution against the potential pitfalls of mass migration to urban centres. Here's a warning from the report. Cities are also places in which the risks associated with warming, such as heat stress, terrestrial and coastal flooding, new disease vectors, air pollution and water scarcity, will coalesce. Unless adaptation and mitigation efforts are designed around the need to decarbonise urban societies in the developed world and provide low carbon solutions to the needs of growing urban populations in developing countries, they will struggle to deliver the pace of scale of change required by 1.5 degrees Celsius consistent pathways. So what's got to be done? According to this report, it'll be nothing short of massive long-term civil engineering projects to implement low carbon or carbon neutral transport, decent water and energy systems in developing countries, and retrofitting cities in developed countries in a way that will be unrecognisable compared to European and North American urban developments of the 20th century. Some cities have already begun development away from the use of fossil fuels through energy efficiency, renewable energy and locally managed smart grids. In Africa and Asia, where people are flooding into cities and urban environments are growing rapidly, there are massive opportunities to capitalise on the fast reducing prices in renewable energy technologies. But they need far stronger governance and regulation if they want to avoid a messy fight for market dominance. At the end of the day, markets are markets and humans are competitive animals. The IPCC report reminds us that buildings are responsible for 32% of all global energy consumption, and that means they've got huge potential to be improved by already existing technologies that increase energy efficiency. But we apparently need to work fast because researchers found that to get anywhere near the IPCC aspiration of a 1.5 degrees Celsius limit to warming, then building emissions would need to be reduced by 80 to 90% by 2050. New construction would need to be fossil fuel free and near zero energy by 2020. And in OECD countries, 5% of all existing buildings would need to be fitted out every single year. That's a lot of work. Visionary architects like Richard Hassel of the WOHA Group and
Stefan Lehmann. I'm a professor of sustainable architecture and the director of the Space Laboratory, which is based in Sydney and Berlin,
are designing and creating astonishing new buildings that can in some cases create more energy than they use. WOHA uses masses of greenery all over their buildings, especially in hot places like Singapore, touted as Asia's greenest city. Plants are pretty much the only thing that don't get hot in the sunshine. They use the sun's energy in photosynthesis to make their carbohydrate building blocks. So covering the outside of your buildings in nature's own insulation is smart design. And then there's the building materials themselves. Stefan Lehmann has put a particular focus on construction using engineered timber. Obviously you have to source the timber from sustainable, managed and replenished sources, but if you use timber to construct buildings on a city scale, then you're locking up huge quantities of carbon within the body of the building material itself, instead of chucking out huge quantities of carbon dioxide making concrete and cement, one of the most carbon intensive industrial processes known to man. Here's what the report says. The United Nations Environment Programme estimates that improving embodied energy, thermal performance and direct energy use of buildings can reduce emissions by 1.9 billion tonnes of carbon dioxide per year, with an additional reduction of 3 billion tonnes a year through energy efficient appliances and lighting. Amongst all this hubris about utopian cities of the future though, the report also reminds us that there's vast numbers of people living in slum areas of some of the largest cities in the world. Huge investments will be needed to transform these areas into properly functioning, energy efficient areas of 21st century cities. But it can be done. The report highlights the Kiasa housing project in Khayelitsha, one of Cape Town's poorest suburbs, where they've created significant mitigation and adaptation benefits by installing ceilings, solar water heaters and energy efficient light bulbs in houses independent of the formal housing or electrification programme. As for getting around these cities, well, according to the report, the global transport sector could reduce 4.7 billion tonnes of carbon dioxide by 2030, but that reduction relies heavily on cities that can minimise the number of journeys, provide incentives for improved fuel efficiency, and that are designed in a way that encourages people to walk, or at least use non-motorised transport like bicycles for shorter commuter distances. Compact, walkable cities also create the passenger density required to make electric or hydrogen-powered public transport, like bus rapid transport or BRT, more financially viable. And they enable urban smart grids where electric vehicles form part of the storage capacity. These principles of spatial organisation of urban energy influence the development of cities as diverse as Hong Kong, Bengaluru in India and Maputo in Mozambique. All this new design and architecture will also need to withstand the ravages of more extreme weather events depending on which part of the world they're in, of course. But one irony is that the countries where building codes and standards will need to be the strictest for that very reason tend to be the very countries where corruption and commercial expediency have historically tended to mean such codes get circumnavigated or ignored altogether, sometimes with tragic results. And it's also crucial that new city developments are realistic and deliverable, and not just vanity projects of mega-rich speculators who then get bored and walk away when the real graft starts, something that's happened dozens of times in China. China is one great big contradiction in many ways. In 2005, it overtook the United States as the world's worst polluter. Since that time, and largely under the leadership and vision of President Xi Jinping, who himself has an engineering background, China has made itself into a world leader in renewable technologies and smart eco-city developments. It's worth spending a minute or two here to think about this Chinese phenomenon. In his brilliant book, China's Urban Revolution, Austin Williams seeks to understand China's fundamental cultural difference compared to Western countries. He cites an interesting comparison between the biblical character Noah and the Chinese semi-mythological character known as Yu the Great. In this extract, Williams explains that when the floods came, Noah builds a boat to survive the rains, but essentially he sits it out. He's a victim of higher forces and can only batten down the hatches. Conversely, Yu, when confronted by potential devastation, builds flood defences, reroutes rivers, dredges channels, constructs canals and tames those forces that threaten his community. Not only are the floods averted, but the raging waters are routed to irrigate the fields, leading to agricultural plenty. Whether you subscribe to this philosophy or not, it certainly makes for a powerful juxtaposition of ideas. But Williams also takes us on a journey through China's 20th century social and political roller coaster, from Mao Zedong's oppressive forced ruralisation of workers to Deng Xiaoping's one-child policy and China's turn towards world markets and capitalism, all the way to the present day and Xi Jinping's ambitious environmental policies. Like it or not, China is the future and it'll soon be the world's largest economy, so we'll all be dealing with our Chinese cousins more and more as the 21st century progresses. Wherever they are in the world, east or west, a big challenge for transitional cities will be the ever-present problems of food and water scarcity. Initiatives like vertical farming can dramatically decrease the amount of land required for food growth and allow cities to be self-sustainable. This vertical farm in Singapore powered by a hydraulic system that uses the same water to rotate the trays as it does to feed the plants, water which is recycled within a closed loop and hasn't had to be changed in the entire 3 years that the farm's been operating, produces 10 times as much produce as the same traditional farm footprint. That's 2 tons of vegetables per day just from this facility alone. These 21st century urban developments will need to work hand in hand with industry to get maximum efficiencies for all the transitional changes that are now urgent and essential. The report says that industry consumes about 1/3 of global final energy and contributes directly and indirectly about 1/3 of global greenhouse gas emissions, which equates to about 14 billion tonnes of CO2 today. By 2050, that number will need to be less than 2 billion tonnes if we want to stay anywhere near 2 degrees of warming instead of the 3 or 4 degrees we're currently on track for. But very few corporations have developed climate adaptation measures. According to the report, industry will need to very quickly embrace these mitigation and adaptation behaviours. The report highlights an age-old challenge that these industries face. In the context of rising demand for construction, an increasing share of industrial production may be based in developing countries. The costs of disruptive change associated with hydrogen or electricity-based production, bio-based feedstocks, and carbon dioxide capture and storage for trade-sensitive industrial sectors, in particular the iron and steel, petrochemical and refining industries, make policy action by individual countries challenging because of competitiveness. In other words, they're all still watching each other like hawks, and nobody wants to jump first because they're all still ruled by the overlord of quarterly earnings reports and shareholder value. But if governments and regulators can strike the right balance, then the desired environmental results are achievable and profits are still there to be had for these corporations, as long as they can do the unthinkable and actually embrace some of these environmental improvements. You just need the vision, belief and courage to give it a go. And that means we need more people like this running things at the top of these industries. Quite a few of whom, by the way, are women, just saying. Nevertheless, there's no denying that many of these new disruptive technologies carry risks with them that governments and businesses are going to have to face up to in the coming years. Bio-based feedstocks, just like the biofuels we looked at last week, might increase pressure on land demand. Electrification of many manufacturing processes will be a really big technological challenge and probably much more disruptive than something like carbon capture. And these disruptive energy transitions could lead to stranded assets, not least in the fossil fuel industry. But with a new generation of business leaders and a dismantling of the old boys network that's existed almost since the dawn of civilization, the potential upsides for long-sighted, forward-thinking businesses could be enormous. In his book, The Third Industrial Revolution, Jeremy Rifkin, an American economic advisor who helped shape the European vision of smart, renewable, distributed energy supplies for the 21st century, offers something of a beacon of hope for how, if we really pull out all the stops, we just might be able to scrape our way out of this century as a viable, functioning species. Well worth a read. So, just a couple of things to add to the notebook before we end. I would suggest all nations to immediately implement much more ambitious policy for adapting existing cities towards energy efficiency, as well as new eco-cities in the relevant geographic locations, and internationally agreed targets for mandatory, rapid and extensive industrial transitional energy technologies. That's it for this week. If you found this programme or the others in the series useful, please do subscribe to the channel to raise our profile with the YouTube search engine algorithms. It doesn't cost you a penny to do that. All you have to do is go to the welcome page on my YouTube channel and hit the subscribe button, and you can get there by clicking here. As always, thank you very much for watching. Have a great week, and remember to just have a think. See you next week.